Hello, this is a test of my newly constructed high voltage capacitor leakage tester, and I have a old wax paper capacitor from a piece of vacuum tube gear, and this is a typical capacitor that goes bad. It should block DC, but block DC and only pass AC, but unfortunately they begin to leak DC, and well, now this is not focusing, but and so anyway, I'm gonna test. Throw the power switch here, turn it on, then I've got a variac back here. I'm gonna turn up the voltage. So we'll start with about 200 volts. So that's 200 volts DC, and the switch right now is in the discharge position. I'll move the capacitor a little bit further away from my hand here, and now when I switch to the test position, we will see this meter rise and then fall a little bit. So it has fallen, but it's not returning all the way to zero. I can repeat the test, go to the discharge position. So this is exhibiting some leakage current. We'll go to discharge and we'll raise the applied voltage. This capacitor is rated for up to 600 volts. So try 400 next, and flip the switch. And we can see this is a very leaky capacitor. We'll see in the next video that, or in the follow-on here, that with a good capacitor we'll see how it behaves. But this is showing some significant leakage current here. We'll go down and adjust the voltage up to 500 volts to the maximum that this equipment is designed to handle. So we can see that as the capacitor is rated for 600 volts, we're applying 500 volts, which is pretty close to full working voltage, and we're still showing about 18 microamps of current. 17, 18 microamperes of leakage current. Alrighty, we'll go back to discharge. And we'll wind down the voltage here. And the internal power supply capacitors are discharging down to zero. And as we can see over here, this is the voltage on the capacitor. Since we're in the discharge position, this tells us the voltage across the capacitor, so now I know that this is safe. I can touch this, no problem. Alright, we're going to put it on pause here for a moment, come back with a good capacitor. Alright, I'm back now with a good capacitor. This is another one from an old piece of tube gear, vacuum tube gear, but it happens to be a much higher quality capacitor. And probably different construction. Probably not paper, but mica, or, well, mica? I'm not certain. Anyway, better mylar. I'm thinking it's a mylar capacitor. Alright, so we'll do the same test now. We'll start up with 200 volts on this guy. Again, this capacitor is rated for 600 or so volts. Alright, please focus. There we go. And I'll throw the switch here. And there we see that the leakage current went back down to 0. Try that again. Let's take the voltage up all the way here. Alright, there we are. We're resuming with this capacitor, the good capacitor. We're now at 500 volts DC. We're going to throw the test switch and see how much leakage it has. And there we can see that it zoomed up, charged, and now it's back down to basically 0 there. So there, ladies and gentlemen, that is a good capacitor. We can switch over here and watch. That just jumps for a tiny little bit there. So now it's safe again. Voltage is gone. Let's watch this guy charge and discharge again. So there he is, back down to 0. So he's resisting. He's charged up to 500 volts and no problems, no leakage current. That's how we want all of our capacitors to behave in our vintage tube gear. Alrighty, thank you, ladies and gentlemen. I will ramp the voltage down here. I'll show safe operating procedures here, leaving the switch in the discharge position. Turn off the power. Alrighty, bye-bye.